The reaction between Coke and Mentos is physical called nucleation. The surface of Mentos is very porous that allowed the soda to dissolve it easily. Mentos plus soda is equals to bubbles. Our soda is an acid, and our bubbles is a gas. What is nucleation? Nucleation, the initial process that occurs in the formation of a crystal from a solution, a liquid, or a vapor in which a small number of ions, atoms, or molecules become arranged in a pattern characteristic of a crystalline solid, forming a site upon which additional particles are deposited as the crystal grows.
Some sources say that sugar reacts with a diet soda to make the fountain. It's a chemical reaction. Other sources say it's a physical reaction caused by the rough texture of the candy. Let's begin by testing the first explanation we heard, that the reaction is caused by a chemical reaction of sugar and diet soda. If the sugar in our Mentos is the cause of our eruption, then we would expect other sweet candy to produce a similar effect. The other candy produced much smaller reactions than the Mentos. The results did not support our hypothesis. Now let's test the second explanation, the idea that the reaction is caused by the rough texture of the Mentos. If a rough texture is all that is needed to produce bubbles, then sand should also produce a reaction. The results support our hypothesis. This explanation is the correct one. Although Mentos candies appear smooth, their microscopic surface is incredibly rough, providing excellent nucleation sites for forming bubbles.
The story of any volcano begins with magma. One of the most common causes of an eruption is an increase in magma static pressure. Magma contains various elements and compounds, many of which are dissolved in the molten rock. At high enough concentrations, compounds like water or sulfur no longer dissolve and instead form high-pressure gas bubbles. When these bubbles reach the surface, they can burst with the force of a gunshot. And when millions of bubbles explode simultaneously, the energy can send plumes of ash into the stratosphere. But before they pop, they act like bubbles of CO2 in a shaken soda. Their presence lowers the magma's density and increases the buoyant force pushing upward through the crust. Not all eruptions are due to rising magmastatic pressure. Sometimes the weight of the rock above can become dangerously low. Landslides can remove massive quantities of rock from atop a magma chamber, dropping the lithostatic pressure and instantly triggering an eruption.
Be more. Be STI.